All right, so we are going to talk about the types of statistical studies. Um, I wanted to make sure that you are also paying attention to whether or not there was an activity. I forgot at the end of the last lesson, there was a sampling activity to go with what we talked about in the last one, so make sure you do that. It is front and back, and make sure you are submitting everything as a single PDF document. Sending me a bunch of JPEGs makes it really hard to do, to grade, because I have to click on like several pages and it really slows it down. So you need to submit everything as a PDF document using any kind of document that you can. You can use a cam scanner app, Adobe app. There's lots of things you can do with your phone. Or if you're anywhere near like the campus, you can go into the library and use a scanner that will turn it all into one PDF document and email it to you to load it up into D2L. The other thing I wanted to talk about was Introduction to Statcrunch project. So you need to buy Statcrunch. It is required for the course. You need to go create an account. You have to log in and go to the home page. Once you get to the home page, at the bottom of the home page there is a survey, and you need to complete the survey at the bottom. And then you can look at the results thus far to see all the people who have taken the survey. Then go back on your home page under Help and Training and watch, so Help and Training, I did not highlight that part. Help and Training, to watch the Statcrunch, Collect, Crunch, Communicate. So you're looking for this icon. So you want to do that. And then so watch this, and then under Basics, watch the Getting Started. It's marked in blue below. And then play with the data groups, or the groups, the surveys, the results and reports section. And the My Data, My Groups, My Surveys, and My Results will not have anything in them because those are going to be your things and you haven't done anything yet. But look around. I want you to investigate. Then I want you to write up a description of what you see on the 4 sections and then upload it into the D2L matching folder. So this paper will be in your D2L. So you're going to do this as well. Okay? All righty. So we're going to talk about the types of statistical studies. Got some more vocabulary, imagine that. So the subjects of a study are the people, the animals, the objects, anything. Anything can be the subjects that are chosen for the sample. If the subjects are people, they may be called participants in the study. So statistical studies, whether observations or experiments, generally are attempts to measure what we call variables of interest. So there's observational study, and there's researchers, where researchers observe or measure characteristics of the subject, but do not attempt to influence or modify the characteristics. There's 2 variations of an observational study, where they're going to observe things that happen. There's a retrospective, where they use data from the past, such as official records or past interviews. And there's a prospective study. It's set up to collect data in the future from groups that share common factors. Okay? And then there's an experimental study, where researchers apply some kind of treatment and observe its effects on the subject of treatment. And then the meta-analysis is where researchers review many past studies. The meta-analysis considers these studies a combined group with the aim of finding trends that were not evident in the individual studies. So we've had a couple of vocabulary words that showed up in here. So let's clarify what those are. We have the variable. That's an item or a quantity that can vary or take on different values. So those are the unknown things. And then the variables of interest are the items or quantities that the study seeks to measure. And then the explanatory variable is a variable that may explain or cause the effect. And the response variable is the variable that responds to changes in the explanatory variable. We'll have a treatment group. Those are the group of subjects who receive the treatment being tested. And if you have a treatment group, you also need to have a control group. This group of subjects do not receive the treatment being tested in experiment. That way we can see what's going on. And then there's going to be confounding variables. Those lead to confusion in a study. Sometimes it's something that occurs that we didn't know about, we didn't plan on, and so it causes confusion in the study. And we'll talk about these in different scenarios here in just a minute. Researchers try to prevent confounding in two ways. They select groups at random. They assign the subject to the treatment and control group at random, meaning that the subject has an equal chance of being assigned to either group, and they need to use sufficiently large groups. So the treatment and control groups are both sufficiently large, so they are unlikely to differ in a significant way, other than receiving or not receiving the treatment. The placebo lacks the active ingredients of a treatment being tested, but looks or feels like the treatment, so the participants do not know whether they're receiving the placebo or the real treatment. We talked about this already in the polio vaccine question, where they received the salt water. So it looked like they got the injection, and that way they don't know. Because there is a thing called the placebo effect. This refers to the situation in which patients improve simply because they believe they are receiving a useful treatment, because they don't know the difference of whether it is the actual treatment or the other, but they're hopeful that it is. Then there's something called the experimenter effect. This occurs when the researcher or the experimenter somehow influences subjects by facial expression, tone of voice, their attitude. So to overcome the experimenter effect, the blinding is used. It keeps people in the dark about who is in which group. That way the experimenter can't influence the response from the subject, because the subject, they're not giving them any like body language clues that, hey, you're in the group, or yeah, you're not, so I don't care. Single blind means that the participants don't know if they're in the treatment group or control group, but experimenters do. And double blind, the participants and the experimenters don't know who's in the treatment group or the control group, so everyone's in the dark. All right, so let's look at the type of study of variables, or and variables. We're going to identify the study as an observational study or an experiment, and then identify the variable. So for example 1, so we are in 1.3. So for example 1, we are looking at part A, a poll in which college students are asked if they commute or live on campus. So, is this an observational or is it an experimental? Well, they didn't do an experiment because they didn't apply any kind of treatment. They were just asking them, right? So they're observing by their responses, do they live on campus or are they commuting? So it's observational, because there's no experiment, and they want to identify the variable. So what's our variable in this question? Well, the variables of interest are going to be the responses to the question, and the proportions of responses. So, in other words, like what is the proportion of what's happening in there for the possible different choices? Do they commute? Do they live on campus? Maybe they refuse to answer. So, they'd be like, no, I don't want to do your study. So in that case, there's going to be some different things going on, and so the proportion of responses will become a variable of interest. There's no cause or effect, like I said, so we don't need to decide whether it's explanatory or a response because it's observational and there's no experimenting going on. All right, Part B. Part B says, a study about growing bell peppers. So let's talk about bell peppers. I've got some visual aids for this one. So I've got some bell peppers here. I grow some different types of bell peppers. Some are big, some are small. So I'm looking at growing some bell peppers. And that's all it says is a study about that. So is this experimental or is this going to be observational? Well, I mean, if you were just looking at them, I guess you're observing them, but it's most likely an experimental one. And let's talk about why. So we're going to call this one experimental because if I'm growing them, I'm probably looking at what can I do with my bell peppers? What are the different things I can do for those? So let's look at our variables of interest. So as I'm growing my bell peppers, I could apply fertilizer, right? And if I'm adding fertilizer, then the fertilizer would become an explanatory, right, variable? Because maybe they grew more because I added fertilizer. So this will be an explanatory. It's going to explain like why the bell peppers grew more. So I had a smaller group, but then I added fertilizer and these guys grew bigger than those. So there was an explanatory variable that happened there. Now, the size of the bell peppers this would be a response variable. They respond when I put the fertilizer in, the bell peppers grew, and so that's a response variable. Now, I started noticing that there was something else going on in my bell peppers, like the leaves were getting eaten and being attacked because there were some bugs. There were bugs in the field. And they were affecting my plants. This is a confounding variable. My plants were doing very good, and then all of a sudden things weren't going so well, and so they were in trouble because they were eating all of the leaves, and so I wasn't getting as many bell peppers. There's just lots of things that can happen with those. So in this case, we're going to also have two other things, the vocabulary words that we talked about. We are going to have a treatment group, and we have a control group. Because of the bugs, I have another situation that happens. So in the treatment group, they're going to get fertilizer and they're going to get insecticide. And in the control group, they get no fertilizer and no, we can do an and no insecticide. All right, so there's a couple of things that are happening here. We're fertilizing because I want to know, does the fertilizing make my bell peppers grow better? Do I get more bell peppers in the group, what's going on. And then that I'm going to be looking at the size of my bell peppers. And then we had that confounding variable because I didn't plan on bugs, so then I had to spray with insecticide or treat it somehow with insecticide because the bugs were, doing stuff. And so that's our confounding, but that also becomes part of the treatment group, and versus the no insecticide, because you've got to have that control group in there. All right, now or you could choose to treat them both with insecticide, and that's not what you're looking at. You're just looking at the fertilizer. You could treat everybody the same with insecticide and just do the fertilizer and see what occurs. Okay? So there's a couple of different ways we can do that. All right, so for example 2, you want to know whether teens who try marijuana are more or less likely to abuse hard drugs as an adult. What type of study should you do? So this one it would be, I can't just ask some teens to try marijuana because that would be unethical, right? And then I'm going to have to wait a while to see if they abuse hard drugs as an adult. So that would take a really long time. What I could do is go look at adults who abuse hard drugs and ask them if they happen to do marijuana as a teenager. So if I'm doing that, what kind of study would that be? This will be example 2. This one's going to be a observational, but specifically it's going to be retrospective. Because we have to look back. We're going to retrospect back and use data from the past. So I can't use, because it would be unethical to say, hey, I need you to do this. So you are going to collect data. To determine if adults who abuse drugs are more or less likely to have tried marijuana as teens. So if you're asking the adults who, and then more or less likely to have tried marijuana than teens, or as teens, than adults, got to clarify, than adults who do not abuse drugs. So you're going to need to collect some data about adults. So if the adults abused drugs, were they more or less likely to have tried marijuana as a teens versus the adults who do not abuse drugs if they did. So you're going to have to find out if the adults who do the drugs, did they also do marijuana? And adults who don't abuse drugs, did they ever use marijuana? And that way you get a retrospective study on the percentage type thing. All right, example 3. So look again at the Salk polio vaccines case study. So that's where we had the 400,000 children, that kind of stuff, that were in the study. So let's go back and refresh our memory on the Salk polio vaccine. I gotta remember where it's at. Oh, there it is. It's right there in front of me. So remember, in 1954, a large experiment was conducted to test the effectiveness of a new vaccine, created by Dr. Jonas Salk. It involved a sample of 400,000 children chosen from the population of all children in the U.S. Half received an injection of the Salk vaccine, the other half contained the placebo of salt water. Among those receiving the vaccine, 33 contracted polio, and 115 cases of polio were among those who did not get the vaccine. Using techniques of statistical science that we'll study later, the researchers concluded that vaccine was effective at preventing polio. All right, so what type of study did they do? That's the first part. Part A was what type of study? Well, in this case, they did an experiment, right? So this is going to be an experiment because they actually gave a treatment. They tested a treatment, which was the vaccine, okay? There was a treatment. If there's a treatment, it's an experiment. All right, part B is the variables. What are the variables? Well, in this case, we have the vaccine is a variable, and we also have polio. Vaccine and polio. There's the disease, and there's the vaccine that's being treated. And for these variables, they can each take on two different values. A child did or did not get the vaccine, or they did or did not contract polio. But in this case, because the study seems to determine whether the vaccine prevents polio, we say the vaccine is going to be the explanatory variable. So it may explain a change in the incidence of polio, and polio is going to be our response variable. It is supposed to change in response to the vaccine. Okay? All right, part C asks, what was the treatment? And well, the treatment is going to be the vaccine, right? And we'll be specific and say it's the Salk vaccine. The next part was which group of children constituted the treatment group? The treatment group, well, they were the ones, they were the children who received the Salk vaccine. And then which was the control group? So the control group are the children who got the salt water, right? The saltwater injection, we also refer to that as the placebo. So they thought they were getting the same thing, but they actually did not get the same thing. All right, and then part D. Part D says, briefly explain how the two strategies for selecting treatment and control groups were used in the study. All right, so the two strategies for selecting the treatment and control group. So let's talk about what happened in the study. So for part D, first of all, there was a total of 400,000 children, right, that participated in the study. We also know that half received the vaccine, and half received salt water. Which was, again, our placebo. So the first strategy, because there's two strategies, the first strategy was implemented by choosing children for two groups, randomly from all the children in the United States, right? All right, so the first strategy was implemented by choosing children for the two groups. Randomly, and that had to be important. They can't just choose them specifically. They had to choose them randomly from among all the children in the United States. And then the second strategy was implemented by using a large number of participants. So a large number of participants, because if they didn't have a big enough group, it wouldn't work very well. So, and let's clarify that. So the two groups were unlikely to differ or be different by chance. So they wanted to make sure they had two solid groups of different children that were randomly chosen, and then they made sure it was really large so it was a good study and not one that could be disputed. Well, you didn't use enough people, it didn't really represent the population. They wanted real results. All right, let's go look at the next part. I'll flip the page here. And part E, what was the placebo in the Salk polio vaccine study? And why did researchers use a placebo in the experiment? All right, so part E, there was the placebo, is the saltwater injection. And then why did the researchers use a placebo in the experiment? So we've talked about that a little bit. So they had to use the placebo for the control group, right? Because if we hadn't used the placebo, then when improvements were observed in the treatment group, we wouldn't have known if that was whether it was due to the vaccine or to the placebo effect, right? They had to know which way. So they had to remove the confounding part of it. All participants had to believe they were being treated in the same way. And that way they ensured that any placebo effect would occur in both groups equally. So the researchers could attribute any remaining differences to the vaccine. So if they only gave a vaccine to group 1, And they'd have placebo effect over here too, right? Because people believe they got the vaccine, blah, blah, blah. And they also got the vaccine. But in group 2, if they got nothing, well, there's no placebo effect here happening. So you'd only have the placebo effect and the vaccine, and you won't know the difference. But if they both got something, they both got an injection, then they both have the placebo effect. So that's not a confounding variable. You know that the overall, you're going to get the vaccine study part. So let's kind of clarify that down. We had to rule out the placebo effect, right? Or have equal placebo effect in both groups. Need equal placebo effect in both groups to remove the confounding variable. Of the placebo effect. Okay, so that's why they have to have that, so that it's equal playing ground, because the kids didn't know either way. All right. Example 4. We have a study divided college students into 2 groups. One group listened to Mozart or other classical music before being assigned to a specific task, and the other group simply was assigned the task without listening to the music. Researchers found that those listening to the classical music performed the task slightly better, but only did the task within a few minutes of listening to the music. The 2 groups performed equally on tasks completed later. Identify the treatment and the control groups. The treatment and the control and treatment groups. All right. So we are on to example 4. Yes, example 4. So the treatment is classical music. And then we have the treatment group. The treatment group are the students who listen to the music. And then the control group are the students who did not listen to the music. Okay? So that one's pretty straightforward. It's not as complicated, I think, because you don't have a whole lot of confounding and stuff going on. All right, example 5. What's wrong with the experiment? We've got 3 cases here. For each of the experiments described below, we're going to identify any problems and explain how the problems could have been avoided. All right, so part A. We've got a new drug for ADHD is supposed to make affected children more polite. Randomly selected children suffering from ADHD are divided into treatment and control groups. The experiment is single blind. That means that the participants, the children with the ADHD, don't know whether or not they're getting the treatment or not, but the experimenters do. Experimenters evaluate how polite the children are doing during one-on-one interviews. All right, so this is example 5, part A. So we've got ADHD kids, and we're trying out this new drug. We want to know if they're more polite. So first of all, the experimenters are assessing politeness, right? But they also know which children receive the real drug. So they might inadvertently speak differently to them. So there might be that body language, right? Because you expect the ones who got the drug are going to be kinder, so maybe you speak a little nicer to them. Where the ones who didn't get it, you might be a little more like irritated because they're not going to be as, you assume they're not going to be as kind. Or they also might interpret the children's behavior differently just because they know which one received it and which one didn't. Oh, these seem nicer and these children didn't because we don't, you know who's who. So that could be the experimenter effect that can confound the study results. So let's look again. We need to identify any problems and then explain how they could have been avoided. All right, so it's going to be experimenter effects. That's the problem that could happen, right? And there's a couple of those. They're assessing politeness. Okay, first of all, that's a matter of opinion, right? So you're deciding if someone's more polite or not. It could be obvious, or maybe it's not super obvious, and so they're like, oh, they got the drug, they are being more polite. They're assessing politeness, body language, tone, from the experimenter, right? Because we're talking about experimenter effects. Could be different. For those who have treatment. Versus those who don't. So with that assessing politeness, they could interpret differently, right? So this could be interpretation. So what should they have done? It should have been a double blind. It should have been a double-blind study or experiment or whatever. Because the experimenter could cause an issue with how the data is being retrieved. Like, because you're like, oh, well, you definitely don't have the drugs, instead of like, well, I don't know. All right, next question, part B. We're going to do the same thing again. Researchers wonder whether drinking coffee before an exam improves performance. 50 coffee drinkers are told not to drink coffee in the 4 hours before the exam, and 50 non-coffee drinkers are asked to drink at least 2 cups of coffee in the 4 hours before an exam. Both groups had the same average performance on the exam. All right, so what's wrong with the study? So I am not a coffee drinker, and if I was forced to drink coffee, it's going to mess me up. I don't do caffeine at all. I do eat some chocolate, but I don't do caffeinated drinks at all. And it's going to make me really jittery, right? Versus people who normally drink coffee and they're like, no, you can't have any coffee. Well, that's going to mess them up in a different way, right? So let's clarify some of that. So both groups took the exam. Under conditions that for them, so that were unnatural, right? For them. It's not natural. They're usually drinking coffee and then they said, no, you can't have any coffee. Or they usually don't have coffee and you made them drink them. So that's going to mess them up right there. Because the coffee drinkers were deprived of their coffee and the non-coffee drinkers were forced to do it. And what this did is this introduced confounding variables, because you changed the situation for both of them. So that's going to be a confounding variable, the fact that you've totally changed what's up to them. This is going to be a difficult to design. So this experiment is difficult to design flawlessly. There's probably going to always be some issues with whatever way you try and do that. You could do the same people, have them take a test with coffee, one without coffee, but it's still, you know, if you do it on different days, then that might be like, did they get more sleep or not enough sleep? I mean, it's going to be hard to keep that all the same. All right, part C. We have a chiropractor performing adjustments on 25 patients with back pain. Afterward, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. All right, so what do we got going on here? We have 25 patients who received adjustments, right? So if they all received treatment, that means they are a treatment group, right? So 25 patients. Okay, so who's our control group? Because if we have a treatment, we need to have a control group. Who's our control group? Well, we only had 25 patients. They all received treatment. There's none. Well, how do you know it worked if you don't also have a control group, right? So some of the patients, they may feel better. There could be a placebo effect. We didn't rule it out with the control group, so we don't know. So it may not have been the treatment. It might have been placebo. Was there one? We don't know. The chiropractor might have improved his study by hiring an actor to do a fake adjustment, one that feels similar but doesn't actually conform to chiropractic guidelines on a control group. Now, you'd have to be careful. There's a whole ethical thing in there, right? But if he had somebody who didn't really do a chiropractic adjustment, it just seemed like he did, then you could have compared the results in the two groups. So this one is not a good study because he did not do that. So he could have hired a fake an actor, or had, even if he didn't do an actor, maybe he even hired like another doctor who knew what he was doing, but not do it. So you might need fake adjustments for the control group, right? That's how those things could have been fixed. All right, let's go on to example 6. We're going to ask again, does it make sense? So Consumer Reports rated house paintings according to how well they hold up to hot weather by conducting an experiment in which they applied the various paints to identical surfaces that were then left exposed to the same hot weather conditions for the same length of time. But I don't believe their results because they did not consider how much the paint costs. Does that make sense? Well, no, that doesn't make sense. So why doesn't it make sense? Well, the variable of interest is going to be the durability of paints in hot weather. That's what they're looking at in this study. How durable are the paints in the hot weather? But they're not trusting the study because they didn't consider how much the paint costs. Well, the cost of paint is irrelevant. It's irrelevant or not relevant. It's not relevant at all. So the study was going along good, and it made sense, and it looked like they were covering everything. They were treating everything the same, but and with all of the different paints, right? Same surface, same weather. But the cost that doesn't have anything to do with it, not at all. So that's why it doesn't make sense, because they're not believing the study because they didn't compare the costs. All right, so you will now have and identify the study activity as well. So make sure you're doing that, and make sure you are doing your homework.